Now here the question is, a vertical line passing through the point h, 0 intersects this ellipse at a point P and Q if tangents to the ellipse at P and Q meet at the point R, if delta h is area of the triangle PQR and delta 1 is maximum of this area and delta 2 is minimum of this area, when the value of h lies between 1 by 2 and 1, then we need to find the value of 8 upon under root 5 delta 1 minus 8 delta 2. So we have this ellipse, and then there is a vertical line passing through this point which is h, 0, and this line, it intersects this ellipse at P and Q. Now for P and Q both, x coordinate will be h, and if we put x as h, then we can write y square as 3 into 1 minus x square by 4. So this y coordinate will be root 3 into 4 minus h square by 2, and here will be this minus root 3 into 4 minus h square by 2. Now it says tangents are drawn at P and Q. If tangents are drawn at P and Q, they'll intersect at this point R, and from symmetry we know that its y coordinate will be 0. Now if we write equation of tangent at P, we know that equation of tangent is given by x1 upon a square plus y1 upon b square, and it is equal to 1. In this case, x1 is this h, so it will be this xh by 4, and then it will be y by 3 into root 3 4 minus h square by 2, and it is equal to 1. Now for x-axis we'll put y as 0, then we'll get the value of x as 4 by h. So this point R will be 4 by h, 0. Now we can write area of this triangle. So area of this triangle, delta h will be this 1 by 2, and then this height will be 2 times under root 3 into 4 minus h square by 2 into this length, which is 4 by h minus h. Now this 2 will cancel. We can add this as root 3 by 2, and it will be this 4 minus h square to the power 3 by 2 upon h. Now we need to find minimum and maximum value of this delta when the value of h lies between 1 by 2 and 1. So we need to find absolute maxima and minima for this function for the given values of h. Now we differentiated with respect to h, we can write d delta upon dh will be root 3 by 2, and then h, and here will be this 3 by 2 4 minus h square to the power 1 by 2 into minus 2h, and then it will be this minus 4 minus h square to the power 3 by 2, derivative of h is 1, whole divided by h square. Now this expression is negative and this expression is also negative, so that means d delta upon dh is less than 0 for all h in this interval. That means this function delta h, it is a decreasing function. Now if it is a decreasing function, it will have its maximum value when the value of h is 1 by 2. So this delta 1 will be when the value of h is 1 by 2. Now if we put value of h as 1 by 2, we write this as root 3 by 2, and then it will be 4 minus 1 by 4 whole to the power 3 by 2 upon 1 by 2. This 2 and 2 will cancel. Now this is root 3, and this is 15 to the power 3 by 2 upon 2 cube, which is 8. Now this is 15 root 15, and 15 root 15 is 45 under root 5 by 8. So That's the value of delta 1. And for delta 2, we'll simply put h as 1. So delta 2 will be when the value of h is 1, and if you put h as 1, it will be this root 3 by 2, and here it is 3 to the power 3 by 2 upon 1, and which is 9 by 2. Now once we have the value of delta 1 and delta 2, we are supposed to find the value of 8 by root 5 delta 1 minus 8 delta 2. Now this is 8 by root 5 and delta 1 is 45 root 5 by 8 and minus 8 into 9 by 2. Now here 8 will cancel, root 5 will cancel, and here it will be this 4, so it will be 45 minus 36, and which is 9. So value of this expression is 9, and that is the answer to this question. Now here the question is, find the minimum value of the expression fx equals ax square plus bx plus c, whose zeros are beta and beta plus 2, which can be obtained by the relation beta equals greatest near function of 2 alpha minus 1, where alpha is given by this limit x tends to 0, 1 minus cos 1 x upon x to the power 4. Now this is 0 upon 0 form. Now we have this standard limit 1 minus cos x upon x square if x is 0. Now if we put x as 0, 1 minus cos x is 0. So we can write this as limit x tends to 0, 1 minus cos x upon 1 minus cos x whole square, and into, we can write this as 1 minus cos x upon x square whole square. Now this is standard limit. This is 1 by 2, and this is also standard limit, which is also 1 by 2. So value of alpha is 1 by 8. Now we are given that beta is greatest near function of 2 alpha minus 1. So value of beta is nothing but minus 1. Now the two roots of this equation are beta and beta plus 2, which is 1. So this equation fx will be x plus 1 into x minus 1, which is x square minus 1. Now if we look at this function, its minimum value will be when the value of x is 0. So this fx, its minimum value will be minus 1 when the value of x is 0. So its minimum value is minus 1, and that is the answer to this question. And actually in this question it should have been this a into x plus 1 into x minus 1, or it will be this a x square minus 1, then it will be this minus a. With minus a, this question doesn't make sense, so we are going along with this minus 1. Now the question is, find the value of this limit n tends to infinite, then this summation r varies from 1 to n, this summation t varies from 0 to r minus 1, 1 upon 5 to the power n, ncr, rct, and 3 to the power t. Now we'll take this out of this summation, because this summation in t, we can write this as limit n tends to infinite, this summation r varies from 1 to n, and will be 1 upon 5 to the power n into ncr, and then this summation t varies from 0 to r minus 1, rct, and 3 to the power t. Now this is ncr into x to the power r, where r varies from 0 to r minus 1. So if it is from 0 to r, it would have been this expansion of 1 plus 3 whole to the power t. So we'll actually write this as this limit n tends to infinite, this summation r varies from 1 to n, 1 upon 5 to the power n, ncr. Now if we look at this series, this is rc0, 3 to the power 0 plus RC1 3 to the power 1 up to RC r minus 1 3 to the power of r minus 1. Now if we add RCR 3 to the power r and if we subtract RCR 3 to the power r, now this is nothing but expansion of 1 plus 3 to the power r minus 3 to the power r. So it will be equal to 4 to the power r minus 3 to the power r. So we can write this as 4 to the power r minus 3 to the power r. Now we'll write this summation as this limit n tends to infinite. We'll take 1 upon 5 to the power n common, and then it'll be this summation NCR 4 to the power r minus NCR 3 to the power r, where r varies from 1 to n. Now we can write this as limit n tends to infinite 1 upon 5 to the power n. Now there is this first term missing, which is NC0 4 to the power 0, which is 1. So we can write this as 1 plus 4 to the power n minus 1, and here it will be 1 plus 3 to the power n minus 1. Now this minus 1 plus 1 will cancel. So we can write this limit as limit n tends to infinite 5 to the power n minus 4 to the power n upon 5 to the power n, which is limit n tends to infinite 1 minus 4 by 5 to the power n. Now this 4 by 5, it is less than 1, and if a is less than 1, then a to the power infinite is simply 0. So value of 4 upon 5 to the power n is 0. So answer to this limit is simply 1. And that's your option C. Now here this first question is, if this limit extends to infinite, eight x cubed plus mx square to the power 1 by 3 minus nx, it exists and is equal to 1, then the value of m by n is. What we'll do is, we'll let x as 1 by t, then this limit will be this limit t tends to 0 positive, and we can write this as 8 upon t cube plus m upon t square to the power 1 by 3 minus n upon t. Now if we simplify this, we can write this as limit t tends to 0 positive. This is 8 plus n t to the power 1 by 3 minus n divided by t, and this limit is equal to 1. Now in order to solve this limit, first we'll check its form. If we put t as 0, we'll get this as 8 to the power 1 by 3, which is 2 minus n upon 0. Now it has to be an indeterminate form to get this result 1. So that means from here we can say value of n must be 2. So if n is 2, then it is 0 upon 0 form. We can use L'Hopital's rule. We can write limit t tends to 0 positive, and it will be this 1 by 3 8 plus mt to the power minus 2 by 3 into m divided by 1, and it will be equal to 1. Now if we put t as 0, we'll get this as 1 by 3, and this is 8 to the power minus 2 by 3n, and it will be equal to 1. Now this is 1 by 12, so value of m is simply 12. Now once we have the value of m and n, the value of m by n will be equal to 12 divided by 2, which is 6, and that's your option B. Now this second question is, this limit x tends to 1 negative 1 plus cos inverse x to the power 1 minus x has the value which are the following. Now in this, what we'll do is, we'll let x as cos theta. Now when x is 1, theta is 0. So from here we can say this theta tends to 0 positive. So we can write this limit as limit theta tends to 0 positive 1 plus theta to the power 1 minus cos theta. Now this is 1, and here it is 0 to the power 0 form. Now we can write this as 1 plus e to the power limit theta tends to 0, 1 minus cos theta into log theta, and we can write 1 minus cos theta as 2 sine square theta by 2 into log theta, which we can also write as 1 plus e to the power limit theta tends to 0, and this is 2 log theta upon cosec square theta. Now this is infinity upon infinity form. So if we use L'Hopital's, we can write this as 1 plus e to the power limit theta tends to 0, and this is 2, 1 upon theta, and here it is this 2 cosec theta by 2, and then cosec theta is minus cosec theta by 2 and cot theta by 2, 1 by 2. Now we can write this as 1 plus e to the power limit theta tends to 0, and this is minus 2 sine theta by 2 sine square theta by 2 tan theta by 2 upon theta, and we multiply and divide it with 2. This is 1 and sine 0 is 0. So this is 1 plus e to the power 0, which is 1 plus 1, and that is 2. So answer to this limit is simply 2. And that's your option B. Now this third question is, if fx is a polynomial function such that f alpha square plus f dash alpha square equals 0. Now assuming that it is a polynomial function with real coefficients, from here we can say f alpha must be 0 and f dash alpha must also be 0. We need to find this limit, which is limit x tends to alpha fx upon f dash x greatest integral function of f dash x upon fx. Now we know that any greater function of x is always less than or equal to x, and it is strictly greater than x minus 1. So from here we can say this greatest integral function of f dash x upon fx will always be less than or equal to f dash x upon fx, and will be strictly greater than f dash x upon fx minus 1. Now we need to multiply it with fx upon f dash x. So if we multiply everything with fx upon f dash x, we can write this as fx upon f dash x into f dash x upon fx minus 1. It is less than fx upon f dash x into greater function of f dash x upon fx, and less than equal to fx upon f dash x into f dash x upon fx. Now I'll cancel. Here this first part will cancel. So we'll get this as 1 minus fx upon f dash x is less than fx upon f dash x into greatest integral function of f dash x upon fx, it is less than or equal to 1. Now if we take this limit x tends to alpha, then we can write this limit x tends to alpha. Here also it will be this limit x tends to alpha, and here also it will be this limit x tends to alpha. So value of this limit on the right hand side, it is 1. We need to find value of this limit on the left hand side. Now this is 1 minus. Now what about this fx upon f dash x? Now if we know that f alpha is 0 and f dash alpha is 0, it means this alpha is double root of this function fx. So we can write this function fx as sum x minus alpha square into, and this f dash x will be sum x minus alpha into hx. So this fx upon f dash x will have x minus alpha and then sum ratio of polynomials px upon qx. Now if we take this limit x tends to alpha, here alpha minus alpha will be 0. So value of this limit is 0. So this expression will take the limiting value 0. So limit on the left hand side is also 1. Now limit on the right hand side is 1. Limit on the left hand side is also 1. Then from sandwich theorem we can say that this limit will be equal to 1. So answer to this limit is 1, and that's your option B. Now here the question is the largest value of the non-negative integer a for which this limit x tends to 1 minus ax plus sine x minus 1 plus a upon x plus sine x minus 1 minus 1 to the power 1 minus x upon 1 minus under root x, it is 1 by 4. We'll put x as 1 minus h. Now we put x as 1 minus h, we can write this as limit h tends to 0. Now if we take these two together, we can write this as a into 1 minus x, and 1 minus x is nothing but h. So we can write this as ah. Now this is sine x minus 1, and x minus 1 will be minus h, and sine minus h is minus sine h. So we write this as ah minus sine h. Now here it is x minus 1, which is minus h, and again sine x minus 1 is minus sine h, and to the power. Now this is a plus b into a minus b, so it will be 1 minus under root x into 1 plus root x upon 1 minus root x. Now since x is unequal to 1, as x tends to 1, we can cancel this. So it will be this 1 plus under root of 1 plus h, and it will be equal to 1 by 4. Now we'll write this as limit h tends to 0, and this is a minus sine h upon h, and this is minus 1 minus sine h upon h to the power 1 plus under root of 1 plus h, and is equal to 1 by 4. Now we know that limit h tends to 0, sine h upon h is 1, and here if we put h as 0, it will be this 2. So we can write this as a minus 1 upon minus 2 whole square will be equal to 1 by 4. Now 1 by 4 and 1 by 4 will cancel. So we get a minus 1 equals plus or minus 1. So value of a is either 0 or value of a is 2. So for this limit, there are two values possible. Either a can take the value 0 or a can take the value 2. But the problem here is, if the value of a is 2, then in this case, it will be this 2 minus sine h upon h, and then this minus 1 plus sine h upon h. Now this is positive, this is also positive, and we have this minus sign. So this exponent will be negative. So it will be some negative number to the power this limit 1 plus under root of 1 plus h. Now since this power is not even, it is a limiting value, and when we say it is a limiting value, it will have many rational and irrational values for this power. So this minus p to this power is not defined when the value of a is 2. So at a equals 2, we have this mathematical inconsistency. So the only option possible in this case is a equals 0. So the largest value of non-negative integer a is 0, and that is the answer to this question. Now the question is, let m and n be two positive integers greater than 1, and if this limit alpha tends to 0, e to the power cos alpha to the power n minus e upon alpha to the power m is minus e by 2, then we need to find the value of m by n. Now what we'll do is, we'll take this e common, so we'll write this as limit alpha tends to 0, and it'll be this e, and then e to the power cos alpha to the power n minus 1 upon alpha to the power n. So we can write this using standard limits as limit alpha tends to 0 e into, and this is e to the power cos alpha to the power n minus 1 upon cos alpha to the power n minus 1 into cos alpha to the power n minus 1 upon alpha to the power n, and this value is equal to minus e by 2. Now this is standard limit, and value of this standard limit is 1. So we write this as limit alpha tends to 0 e, and we know that if we take this minus common, we can write this as 1 minus cos alpha to the power n, and if we divide and multiply it with alpha to the power 2n, then this also becomes standard limit whose value is 1 by 2. So we'll put 1 by 2 here. Now 2 will cancel, minus e will also cancel. So from here we'll get this condition that value of m must be equal to 2n. So value of m by n must be 2, and that is the answer to this question. Now here the question is, let fx be a continuous odd function which vanishes exactly at one point. Now it is continuous odd function, and we know that for odd function f0 is 0 and f1 equals 1 by 2. That means this function, it will be in first and third quadrant with value at 0, 0, and at 1 this value is 1 by 2. Now we are given that capital Fx is this integral from minus 1 to x ft dt, and capital Gx is this integral from minus 1 to x t into mod of f of ft dt for all x belongs to minus 1 to 2. Now it is given that this limit x tends to 1 fx upon gx is 1 by 14. Now we'll write this as this limit x tends to 1, and then this integral from minus 1 to x ft dt upon this integral from minus 1 to x t into mod of f of ft dt, that is equal to 1 by 14. Now if we put x as 1, then limits of this integral will be from minus 1 to 1, and we know that fx is an odd function. So integral of an odd function from minus a to plus a will be simply 0. In the same way, this integral from minus 1 to 1 t into mod of f of ft dt. Now ft is odd, f of ft will be odd, but this mod sign, it makes an even function, and this t is odd, so this function is an odd function. So again value of this integral will be 0. So this is 0 upon 0 form. Now if it is 0 upon 0 form, we can use L'Hopital's rule. So if we differentiate this, we can write this as this limit x tends to 1 fx, and here will be this x into mod of f of fx, that is equal to 1 by 14. Now if we put x as 1, we write this as f1 upon mod of f1, that is equal to 1 by 14. Now in the question it is given that value of f1 is 1 by 2. So it will be this 1 by 2 upon mod of f1 by 2 will be equal to 1 by 14, or mod of f1 by 2 is equal to 7. Now since fx is positive when x is greater than 0, so we can write f1 by 2 is actually plus 7. Value of f1 by 2 is 7, and that is the answer to this question. Now in the questions we are given that f dash x equals 2 minus fx upon x for all x belongs to 0 to infinite, and f1 is unequal to 1, then which of the following is correct? Now we can write this as f dash x plus fx upon x, and it is equal to 2. Now this is dy by dx plus y by x equals to, which is linear equation in y. So in this we'll calculate this integrating factor, which is e to the power integral of 1 upon x dx, and which is e to the power log x, which is nothing but x. Now we write answer to this differential equation. So it will be this y into integrating factor, and it will be this integral 2x dx. So we can write x into y will be equal to x square plus c, or y equals x plus c upon x. Now if we put x as 1 and y as 1, we'll get value of c as 0, but it is given that when x is 1, y is unequal to 1. So it clearly means value of c is unequal to 0. So we have this value c unequal to 0. So now we have our function fx. So this fx is x plus c by x. And if we find f dash x, will be 1 minus c upon x square. Now f dash 1 by x will be 1 minus c x square. Now if we take this limit x tends to 0, value of this limit will be 1. That means this option A, it is correct. Now if we look at this option B, which is limit x tends to 0 positive x, and f1 by x will be 1 by x plus cx. Now this is 1 plus cx square, which also is 1, but it is given as 2, so this option B will be incorrect. Now this third one is x square into f dash x. That will be this limit x tends to 0 x square, and f dash x is 1 minus c upon x square. So it will be this x square minus c. So value of this limit is minus c, and since c is unequal to 0, it can never be equal to 0. That means option C is also incorrect. Now if we look at this option D, then we know that mod of fx is x plus c upon x. Now we know that x plus c upon x by 2 will always be greater than or equal to its geometric mean, which is under root c, or we can write x plus c upon x will always be greater than or equal to 2 root c. Now depending on value of c, this expression on the left hand side can take any value. That means this option D is also incorrect. So the only correct option is this option A. Now here we are given that this limit x tends to 0 x square sine beta x upon alpha x minus sine x, it is equal to 1. We need to find the value of 6 alpha plus beta. Now we'll solve this question using expansion. Now we'll write this as x square, and this sine beta x will be beta x minus beta x whole cube upon factorial 3 and higher powers of x divided by, and in the denominator will be this alpha x minus, and here will be this x minus x cube upon factorial 3, and we are given that this limit is equal to 1. Now since this limit is x tends to 0 and minimum power of x in the numerator is 3, this limit will have a finite non-zero answer if minimum power in the denominator is also 3. That means this alpha minus 1 into x term, it should not be there in the denominator. So clearly it should be 0. So from here we can find value of alpha is 1. Now if we put alpha as 1, then minimum power in the numerator is 3 and minimum power in the denominator is also 3. So answer to this limit is coefficient of x cube in the numerator upon coefficient of x cube in the denominator. Now coefficient of x cube in the numerator is beta, and coefficient of x cube in the denominator is 1 by root 3, which is 1 by 6, and it is 1. So value of beta is 1 by 6. Now we need to find the value of 6 alpha plus 6 beta. Now 6 alpha is 6 and plus 6 beta is 1. So value of this expression is 7, and that is the answer to this question. Now the question is, a function is defined from R to 0 to infinite and gx be twice differentiable functions such that f dash and g double dash are continuous functions on R. Now it is given that suppose f dash 2 equals g2 equals 0 and f double dash 2 is unequal to 0 and g dash 2 is also unequal to 0, we need to find this limit, which is limit x tends to 2 fx into gx upon f dash x into g dash x, and it is equal to 1. Now first we'll check this form. Now it is f2 into g2, and g2 is 0 and f dash 2 is 0, so it is 0.0 form, and when it is 0.0 form we'll use L'Hopital's rule. So we'll write limit x tends to 2. Now this is fx into g dash x plus gx into f dash x upon f dash x into g double dash x plus g dash x into f double dash x, and it is equal to 1. Now we'll put this limit. So we'll write f2 into g dash 2 plus g2 into f dash 2 upon f dash 2 g double dash 2 plus g dash 2 into f double dash 2, and it is equal to 1. Now we know that g2 is 0. So this expression will be 0, and also f dash 2 is 0. So it will also be 0. Now g dash 2 and g dash 2 will cancel. So we'll get f double dash 2 equals f2, and which is unequal to 0. Now in the question it says its codomain is from 0 to infinite. That means this f double dash 2, which is equal to f2, it is greater than 0. Now if we look at f dash 2, we know that f dash 2 is 0 and f double dash 2 is greater than 0. That means this 2 is a point of local minimum. So that means this option 8 is correct. That means this option B will be incorrect, and clearly f double dash 2 is equal to f2. That means this option C is also incorrect. Now it says fx minus f double dash x equals to 0 for at least one x belongs to R. We know that this is true for x equals 2. That means this option D is also correct. So the correct options are A and D. Now here the question is, it says if fx is a differentiable function such that f0 is 0, f pi by 2 is 3 and f dash 0 is 1, if gx is this integral from x to pi by 2 f dash t cosec t dt minus this integral from x to pi by 2 cot t cosec t into ft dt, then we need to find this limit x tends to 0 positive gx, since gx is only defined in the right neighborhood of 0. Now what we'll do is we'll solve this question taking cosec t as first function and f dash t as second function. So it will be cosec t and then integral of f dash t will be ft, and then limits are from x to pi by 2 minus this integral from x to pi by 2. Now derivative first, derivative of cosec t is minus cosec t cot t, and then integral of f dash t is ft dt, which will get cancelled with this other expression, which is the same integral from 0 to pi by 2 cot t cosec t ft dt. So this gx will be cosec pi by 2, which is 1, and then it will be this f pi by 2 minus fx upon sin x. Now f pi by 2 is 3, so value of gx is 3 minus fx upon sin x. Now we need to find this limit x tends to 0 positive gx. So if we take this limit x tends to 0 gx, will be this 3 minus this limit x tends to 0 fx upon sin x. Now f0 is 0 and sin 0 is 0, so it is 0 upon 0 form. So we can use L'Hopital's rule. So it will be this 3 minus limit x tends to 0 f dash x upon cos x. Now this is 3 minus f dash 0 is 1 and cos 0 is also 1. So 3 minus 1 is 2. So answer to this limit is simply 2. Now here the question is, we are given this function fx and we need to find its left hand and right hand limit at x equals 1. Now if we look at left hand limit, it will be this limit x tends to 1 negative, and this is 1 minus x into 1 plus mod of 1 minus x upon mod of 1 minus x into cos 1 upon 1 minus x for all x unequal to 1. Now when x is less than 1, then mod of 1 minus x will be simply 1 minus x. So we write this as this limit x tends to 1 negative 1 minus x into 2 minus x upon 1 minus x into cos 1 upon 1 minus x. Now this is limit x tends to 1 negative, and here will be this x square minus 2x plus 1 upon 1 minus x cos 1 upon 1 minus x. Now this is 1 minus x whole square, which will cancel with 1 minus x. So will be this limit x tends to 1 negative 1 minus x into cos 1 upon 1 minus x. Now we check it forms before solving it. Now this is 0 into, and this is cos infinite, and cos infinite is oscillating value from minus 1 to 1. Now 0 into anything finite is 0. So answer to this left hand limit is 0. That means this option A it is correct, and option B will be incorrect. Now we'll find its right hand limit. Now for right hand limit, it will be this limit x tends to 1 positive. Now if x is greater than 1, then 1 minus x mod will be simply x minus 1. So we'll get 1 minus x into 1 plus x minus 1 upon, and this is cos 1 upon 1 minus x. Now here 1 and 1 will cancel. Now this is 1 minus x square, so we can write this as this limit x tends to 1 minus 1 plus x into cos 1 upon 1 minus x, which is minus 2 into cos infinite, which is oscillating value from minus 2 to plus 2. And since this value is oscillating, so this limit does not exist. So this right hand limit does not exist. So the correct options are A and D. Now here the question is, for each positive integer n, let yn equals 1 upon n, and here we write this as this product r varies from 1 to n plus r whole to the power 1 by n. Now we'll take this n inside, so we can actually write this as yn, and it will be this product r varies from 1 to n, and this n upon n will be 1, and it will be 1 plus r by n whole to the power 1 by n. Now if we take log both sides, we can write log yn, and it will be this summation, because product will convert into sum. Summation r varies from 1 to n, and will be this 1 by n log 1 plus r by n. Now we need to find this limit n tends to infinite. So we'll take this limit n tends to infinite. That satisfies all the three conditions for limit of sum. It is n tends to infinite. We have 1 by n, and then we also have r by n. So we can actually write this as log yn will be equal to this integral log 1 plus x dx. So we'll change this 1 upon n as dx and r upon n as x, and then we'll change this summation into integral. Now when r is 1, x is 1 by n, 1 by infinity is 0, and when r is n, n upon n is 1. So it will be this integral from 0 to 1 log 1 plus x dx. So we write this as log yn, and this is 1 into log this. So we'll use by parts. So this is log 1 plus x into x minus this integral from 0 to 1, 1 upon 1 plus x into x dx. Now we'll put the limits from 0 to 1, and here we'll add 1 and subtract 1. So we can write log yn, and here will be this log 2 minus 0 and minus. Now this is from 0 to 1, 1 minus 1 upon 1 plus x dx. So it will be this log by n, and it will be log 2 minus 1 plus log 1 plus x from 0 to 1. So it will be this log yn, and it will be 2 log 2 minus 1, which is log 4 upon e. So value of yn will be simply 4 by e. Now it says we need to find greatest integral function of this limiting value L. So greatest integral function of L will be greatest integral function of 4 upon e, and which is 4 upon 2.7 something, which is 1 point something. So value of this greatest integral function is 1, and that is the answer to this question. Now for this question, we are given this function f and x, which is this summation. J varies from 1 to n, tan inverse, and this is 1 plus x plus j into x plus j minus 1, and the numerator we can write this one as x plus j minus x plus j minus 1 for all x belongs to 0 to infinite. Now this is tan inverse x minus y upon 1 plus xy, which is tan inverse x minus tan inverse y. So we'll write this f and x as this summation. J varies from 1 to n, tan inverse x plus j minus tan inverse x plus j minus 1. Now if we put j as 1, it will be this tan inverse x plus 1 minus tan inverse x, plus if we put j as 2, it will be tan inverse x plus 2 minus tan inverse x plus 1, and will continue up to tan inverse x plus n minus tan inverse x plus n minus 1. Now here in this case, tan inverse x plus 1 will cancel. So all these terms, they'll keep getting cancelled. So we'll have this term, and in the end we'll also have this term. So this f and x will actually be tan inverse x plus n minus tan inverse x, which we can also write as f and x, now tan inverse n upon 1 plus x square plus nx. Now the first option, it says fj0. Now 0 is not included in the domain, so that means we cannot define f0 or f'0. So option A and B, they are definitely incorrect. Now we need to look at this limit x tends to infinite, tan f and x. So it will be this tan, and then this limit x tends to infinite, and f and x is tan inverse n upon 1 plus x square plus nx. Now if x tends to infinite, it will be n upon infinite, which is 0, and tan inverse 0 is 0. So answer to this limit will be 0. That means this option C is also incorrect. Now if we look at this option D, then in that case it will be this secant square, and then this limit x tends to infinite, tan inverse n upon 1 plus x square plus nx, and we know that this limit is 0, so it will be this secant square 0 and secant square 0 is 1. So that means the only correct option is this option D. Now here we are given that this function is defined from 0 to pi to r, and it is such that this limit t tends to x, fx sin t minus ft sin x upon t minus x, it is equal to sin square x for all x belongs to 0 to pi. Now we put t as x, it will be 0 upon 0 form, and if it is 0 upon 0 form, we can use L'Hopital's rule. So we'll differentiate this numerator and denominator with respect to t. So it will be this fx, and derivative of sin t is cos t minus f dash t into sin x upon 1, and this limit t tends to x, and it will be equal to this sin square x. Now we can write this as fx cos t minus f dash x sin x, and it will be equal to this sin square x. Now we can write this as f dash x minus fx cot x, and it will be equal to minus sin x, which is a linear function in y. Now we will find its integrating factor. Its integrating factor will be e to the power minus integral of cot x dx, and it will be e to the power minus log sin x, which is nothing but cosec x. So we solve this integral, we'll get fx into cosec x will be equal to this integral and minus sin x into cosec x. So it will be this minus 1 dx, which is minus x plus c. So we can write this function fx as minus x sin x plus c sin x. Now we are given that f pi by 6 is minus pi by 12. So if we put x as pi by 6, f pi by 6 is minus pi by 12, and here will be this minus pi by 6, and sin pi by 6 is 1 by 2 plus c into 1 by 2. I'll cancel, value of c is 0. So from here we'll get this function fx as simply minus x sin x. So in our case, this function fx is minus x sin x. Now we have to find which of the following options is or are correct. Now this first one is f pi by 4. Now f pi by 4 is minus pi by 4, and sin pi by 4 is 1 by root 2, so it will be minus pi upon 4 root 2. Option A is incorrect. Now B is fx is less than equal to x to the power 4 upon 6 minus x square. Now we know that fx is minus x sin x, and sin x is x minus x cube upon 6 plus x to the power 5 upon factorial 5. Now this is minus x square plus x to the power 4 upon 6 minus x to the power 6 upon factorial 5. Now it is this expression minus some value. That means it is always less than minus x square plus x to the power 4 by 6. That means this option B is correct. The actual way to solve this question is to prove first that this is true when x belongs to 0 to 1, and second, it is true for x belongs to 1 to infinite. But this part is fairly simple. So we'll take this option B. Now in C it says there exists alpha belongs to 0 to pi such that f dash alpha is 0. Now for C we know that f0 is 0, f pi is 0, and this function is continuous and differentiable. Then using Rolle's theorem, we know that there is at least one alpha in the interval 0 to pi such that f dash alpha is 0. So that means option C is also correct. Now option D is we need to find f double dash pi by 2 plus f pi by 2. Now f pi by 2, it is minus pi by 2. If we differentiate this, f dash x will be minus x cos x minus sin x. And if we differentiate this again, f double dash x will be minus x and minus minus plus will be this sin x minus cos x and will be this minus cos x. So f double dash pi by 2 will be this plus pi by 2 and cos 90 is 0. Now if we add them, plus pi by 2 and minus pi by 2, they will cancel. So this value will be 0. So the correct options are B, C and D. Now here the question is, for non-negative integers n, we are given this function fn in terms of summation and sign. Then we need to find which of the following options is or are correct. Now for this, what we'll do is we'll let pi upon n plus 2 as some constant, say theta. So we'll actually write this as fn is this summation, k varies from 0 to n sine k plus 1 theta into sine k plus 2 theta whole divided by this summation, k varies from 0 to n sine square k plus 1 theta. Now we'll multiply and divide it with 2. Now this is 2 sin A sin B, and we know that 2 sin A sin B is cos A minus B minus cos A plus B. So it will be this summation, k varies from 0 to n and cos A minus B. So it will be k plus 2 theta minus k plus 1 theta. It will be simply cos theta minus this summation, k varies from 0 to n, and it will be cos A plus B, and that will be 2k plus 3 into theta. And the denominator will be this summation, k varies from 0 to n and 1 minus cos 2 theta. So it will be cos 2 into k plus 1 theta. Now since theta is independent of k, this summation cos theta is summation of constant. So it will be this n plus 1 into cos theta. So we can write fn as n plus 1 cos theta minus this summation, k varies from 0 to n cos 2k plus 3 theta upon this summation 1 will also be n plus 1 minus this summation, k varies from 0 to n cos 2 into k plus 1 theta. Now first we'll simplify these two summations. Now this first summation is summation k varies from 0 to n cos 2k plus 3 theta. Now if we put k as 0, so it will be this cos 3 theta, cos 5 theta, cos 7 theta up to cos 2n plus 3 theta, where angles are in AP. Now in this case, value of alpha is 3 theta and value of beta is 2 theta. That's your common difference. We know that sum of this series is sine n beta by 2. N beta by 2 will be, number of terms is n plus 1 and beta by 2 is theta upon sine beta by 2, which is sine theta, into cos alpha plus, which is 3 theta plus n minus 1, which in this case is n, into beta by 2, which is theta. So it will be this sine n plus 1 theta into cos n plus 3 theta whole divided by sine theta. And if we look at this second series, which is this summation k varies from 0 to n cos 2k plus 1 theta will be this cos 2 theta plus cos 4 theta. Now in this case, alpha equals beta equals 2 theta. Number of terms is n plus 1 and again angles are in AP. So we can write this as sine n beta by 2, so will be this sine n plus 1 theta upon sine theta into cos a plus n minus 1 into theta. So it will be this sine n plus 1 theta into cos n plus 2 theta will divide by sine theta. So now we have result for both the summations. So we can write this function fn as n plus 1 cos theta minus this sine n plus 1 theta cos n plus 3 theta upon sine theta divided by n plus 1 minus sine n plus 1 theta into cos n plus 2 theta upon sine theta. Now we have taken pi upon n plus 2 as theta, so we can write n plus 1 theta as pi minus theta. So sine n plus 1 theta will be sine theta and n plus 2 theta will be simply pi. So sine n plus 1 theta and sine theta will cancel, and here we'll get this as n plus 1 cos theta minus cos. Now n plus 2 theta is pi, so it will be this pi plus theta, and here will be this n plus 1 minus cos pi. Now cos pi plus theta is minus cos theta, so here will be this minus minus plus, so we can write this as cos theta into n plus 2 upon n plus 2, and will also cancel. So basically this function fn will be cos pi upon n plus 2. So now we have our function fn, which is cos pi upon n plus 2. Now the first part is f4. Now this f4 is cos pi by 6, and cos pi by 6 is root 3 by 2. That means option A is correct. Now f6 will be cos pi by 8. Alpha is tan of cos inverse f6, and cos inverse f6 is pi by 8. So it will be this tan pi by 8, and tan pi by 8 is simply root 2 minus 1. Now we take this one on the left hand side in square, we get alpha square plus 1 plus 2 alpha will be equal to 2, or alpha square plus 2 alpha minus 1 equals 0. That means this option B is also correct. Now for this C, we need to find f5. f5 is cos pi by 7. Now sine 7 cos inverse f5 will be sine 7 pi, and sine 7 pi is 0. That means option C is also correct. And then this limit n tends to infinite, fn will be this limit n tends to infinite cos pi upon n plus 2. Now this is cos 0 and cos 0 is 1. So option D is incorrect. So the correct options are A, B and C. Now here the question is, if E denote the base of natural logarithm, then the value of real number A for which the right hand limit x tends to 0 positive 1 minus x to the power 1 by x minus e to the power minus 1 upon x to the power a is equal to a non-zero real number. Now we'll solve this question using expansion. So we'll use the expansion of 1 minus x to the power 1 by x. Now one of the way to find this expansion is using Maclaurin series, which we have covered in one of the previous videos. Now since we are assuming it's for JEE, we are not going to use Maclaurin series in this case. So what I'll do is I'll say, suppose this expansion is y, and we can write this as e to the power log 1 minus x to the power 1 by x, which is e to the power 1 by x log 1 minus x. Now we'll use the expansion of log 1 minus x. So it will be this e to the power 1 by x, and it is minus x square upon 2 minus x cube upon 3, so on and so forth. So it will be this e to the power minus 1 minus 1 by 2x minus x square by 3. Now we'll take e to the power minus 1 common. We can write this as e to the power minus x by 2 minus x square by 3 up to infinite. Now this is expansion of e to the power minus x, and we know that expansion of e to the power minus x is 1 minus x, and x in this case is x by 2 plus x square by 3 and plus x square upon factorial 2. Now we are just concerned with first few powers. So in this case, if I take square of the series, then the term I'll get is x square upon, now this is 4 and 2 will be this 8. So we'll get this as e to the power minus 1 minus x by 2, and then it'll be this minus x square by 3 plus x square by 8. So it'll be this minus 5x square by 24. Now we use this expansion to solve this limit. Now we put this expansion in this limit. We can write this limit as limit x tends to 0 positive, and here it will be e to the power minus 1 minus x by 2 minus 5x square by 24, and then minus e to the power minus 1 upon x to the power a. Now e to the power minus 1 will be cancelled. Now minimum power of x in the numerator is 1. So this limit will have a non-zero real number answer if the minimum power in the denominator is also 1. That means value of a must be 1 in this case. So the value of real number a, it must be 1, and if it is 1, then answer to this limit will be minus 1 upon 2e. Now here the question is, we need to find the value of this limit. Now this is limit x tends to pi by 2, that is 4 root 2 sine 3x plus sine x whole divided by 2 sine 2x into sine 3x by 2. And what we'll do is we'll take these two together. So we'll write this as cos 5x by 2 minus cos 3x by 2, and then minus, we'll take root 2 common, and it will be 1 plus cos 2x. Now we'll use trigonometric formulas. So we'll write this as limit x tends to pi by 2. Now this is 4 root 2. Now sin c plus sin d is 2 sin c plus d by 2. So it will be 2 sin 2x into cos c minus d by 2. So it will be into cos x in the denominator we have this 2 sine 2x into sine 3x by 2. Now this is cos c minus cos d. So it will be 2 sine c plus d by 2, and there will be 8x upon 4. So it will be this sine 2x and then sine d minus c by 2. So there will be sine x by 2 with a minus sign. And here will be this root 2 and this is 2 cos square x. Now here what we'll do is we'll take 2 sine 2x common. So we'll write this as limit x tends to pi by 2 and this is 8 root 2 sine 2x into cos x, and here if we take 2 sine 2x common, we are left with sine 3x by 2 minus sine x by 2. Now sine c minus sine d is 2 sine c minus d by 2, which is sine x by 2 into cos c plus d by 2, which is cos x minus 2 root 2 cos square x. Now since limit is x tends to pi by 2, we have problem with cos x. So what we'll do is we'll write sine 2x as 2 sine x into cos x. So now we'll write this limit as this limit x tends to pi by 2 and this is 16 root 2 sine x into cos square x, and here it will be 8 sine x into sine x by 2 into cos square x minus 2 root 2 cos square x. Now cos square x will cancel. If we put this limit, we'll get this as 16 root 2 upon, now this is 8 and sine pi by 2, and sine pi by 2 is 1 and sine pi 4 is 1 by root 2 minus 2 root 2. So it is 16 root 2 upon 2 root 2, which is 8. So answer to this question is 8. Now here the question is, we are given this limit n tends to infinite, and we can write this numerator as this summation r varies from 1 to n r to the power 1 by 3, and this is n to the power 7 by 3, and plus this summation r varies from 1 to n 1 upon a n plus r whole square. Now here we'll take n square common, so we can write this as this limit n tends to infinite. Now n square will cancel with n square, we'll get n to the power 1 by 3, and we'll take n to the power 1 by 3 with r to the power 1 by 3. So we can write this as this summation r varies from 1 to n, and it will be this r by n to the power 1 by 3, and here it will be this summation r varies from 1 to n, that is 1 upon a plus r by n whole square. Now what we'll also do is we'll multiply numerator and denominator with 1 by n. Now it satisfies all the three conditions for limit of sum. Now we have n tends to infinite, we have 1 by n, and we have r by n. So we'll replace r by n with x. So it will be this integral and then x to the power 1 by 3 dx. Now when r is 1, it is 1 by n, and 1 by n is 1 by infinite 0, and upper limit is n by n, which is 1 upon, and for this also we can write this integral from 0 to 1 dx upon a plus x whole square, and it is given that it is equal to 54. Now it will be this x to the power 4 by 3 into 3 by 4 from 0 to 1, and here it will be minus 1 upon a plus x from 0 to 1, and it is equal to 54. Now this is 3 by 4, and here it is 1 upon a minus 1 upon a plus 1, and it will be equal to 54. Now this is 18. So we'll get a square plus a equals, which is 8 into 9. So it will be this a plus 9 into a minus 8 equals 0. So value of a is either minus 9 or value of a is 8. So the options are A and D. Now the question is, we are given a function f from R to R, and it says f has property 1 if this first limit exists and is finite, and it has property 2 if this second limit exists and is finite. Now option A is this function x mod x has property 2. Now for property 2, we write limit h tends to 0. Now fh is h into mod h minus f0 is 0 upon h square. Now if h is less than 0, value of this limit is minus 1, and if h is greater than 0, value of this limit is plus 1. So this limit does not exist. That means this option A, it is incorrect. Now if we look at this option B, it says sin x has property 2. So again we look for this limit h tends to 0, fh is sin h minus 0 upon h square. Now sin h upon h is 1, and here will be this 1 by h, and 1 by h approaches plus infinite and minus infinite for h tends to 0 positive and 0 negative. That means this option B is also incorrect. Now this C is fx equals mod x is property 1. Now for property 1, it will be this limit h tends to 0. Now fh is mod h minus 0 upon under root of mod h, which will be under root of mod h, which is simply 0. That means this function satisfies property 1. And for D, x to the power 2 by 3. So we can write limit h tends to 0, h to the power 2 by 3 minus 0 upon mod of h to the power 1 by 2. Now since it is h square, we can actually write this as mod of h to the power 2 by 3 minus 1 by 2, which is mod of h to the power 1 by 6, which again will be 0, which exists and is finite. So that means the correct options are C and D. Now here the question is, for any positive integer n, let Sn be defined as this summation k varies from 1 to n cot inverse of 1 plus k into k plus 1 x square upon x, and we write this x as k plus 1x minus kx. Now if we take its reciprocal, we can write it in terms of tan inverse, and it is tan inverse x minus tan inverse y. If we take its reciprocal, then we can write it in terms of tan inverse, and we know that tan inverse x minus y upon 1 plus xy, it is tan inverse k plus 1x minus tan inverse of kx. Now we'll simplify this summation. When k is 1, it will be tan inverse 2x minus tan inverse x plus tan inverse 3x minus tan inverse 2x, and we'll continue up to tan inverse n plus 1x minus tan inverse of nx. Now these terms, they'll cancel. Now since this second one here, in the end, it will be this term. So we can write this Sn as tan inverse n plus 1x minus tan inverse of x, or we can write this as tan inverse nx upon 1 plus n plus 1 into x square. So that's a function Snx. Now domain of this function is from 0 to infinite to R. Now in this first option, it says S tan x. Now for as 10x, we'll put n as 10. So it'll be this 10 inverse of 10x upon 1 plus 11x square. Now we can write this as cot inverse of 1 plus 11x square upon 10x. And we know that cot inverse x is pi by 2 minus tan inverse x. So it will be pi by 2 minus tan inverse 1 plus 11x square upon 10x. That means this option A, it is correct. Now for this option B, we need to take this limit. Limit n tends to infinite cot, and then it will be this tan inverse. And since it is infinite limit, we look at highest power of n. In the numerator it is 1. In the denominator also it is 1. So answer to this question will be coefficients of n. So coefficient of n in the numerator is x and in the denominator is x square. Now we know that tan inverse 1 by x is cot inverse x and cot of cot inverse x is x. So this value will be x. Now for this C it says S3x equals pi by 4. Now what is S3x? It will be tan inverse of 3x upon 1 plus 4x square, and we put it equals to pi by 4. Now we can write this equation as 4x square minus 3x plus 1 equals 0. Now discriminant for this quadratic equation is 9 minus 16, which is less than 0. So this equation will have no real root. So C is incorrect. Now in part D it says tan of S and X is always less than equal to 1 by 2 for any n greater than equal to 1 and x greater than 0. Now what we'll do is we'll take this as some function y, and this y will be nx upon 1 plus n plus 1 x square. Now we'll find its absolute maxima and minima when x is greater than 0. Now we find dy by dx. dy by dx will be 1 plus n plus 1 x square into n minus nx into n plus 1 into 2x upon 1 plus n plus 1x whole square. Now here we'll take this n common, then we can write 1 plus n plus 1 x square, and here will be minus 2 n plus 1 x square upon 1 plus n plus 1 x whole square. Now we solve this, we'll get two critical points, plus or minus 1 upon under root of n plus 1. Now it will be minus 1 upon under root n plus 1 and plus 1 upon under root of n plus 1. Now we do not know anything when x is less than 0. So we are just concerned with this point. Now rightmost it is minus and then it is plus. So we'll have a local maxima when x is 1 upon under root of n plus 1. So this maximum value of y, it will be n upon under root of n plus 1 and 1 plus n plus 1, 1 upon n plus 1, so it will cancel. So it will be this n upon 2 under root of n plus 1. Now it is always greater than n upon twice under root n, and we can write it is greater than under root n by 2. Now since n is greater than 1, then this value is greater than 1 by 2. So its maximum value is actually greater than 1 by 2. That means this option D is incorrect. So the correct options are only A and B. Now here the question is, we need to solve this limit x tends to 1 log 1 plus x minus log 2 3 into 4 to the power x minus 1 minus x upon, and this is 7 plus x to the power 1 by 3 minus 1 plus 3x to the power 1 by 2 sine x minus 1. Now what we'll do is, we'll use substitution here. We'll write let x equals 1 plus h. Then we can write this limit as limit h tends to 0 log 2 plus h minus log 2, and here will be this 3 into 4 to the power h minus 1 minus h upon 8 plus h to the power 1 by 3 minus 4 plus 3h to the power 1 by 2, and here will be this sine h. Now we can write this as limit h tends to 0 log 1 plus h by 2, and we'll take sine h here, and we'll write 3 into 4 to the power h minus 1 minus h upon 8 plus h to the power 1 by 3 minus 4 plus 3h to the power 1 by 2. Now here what we'll do is, we'll multiply and divide it with h. Now sin h upon h is 1, and here we'll also multiply and divide it with 2. So log 1 plus h by 2 upon h by 2, it will be 1. So now we are left with limit h tends to 0 3 by 2, and then it is 4 to the power h minus 1 minus h upon 8 plus h to the power 1 by 3 minus 4 plus 3h to the power 1 by 2. And we put h as 0, it is 0 upon 0 form. And once it is 0 upon 0 form, we use L'Hopital's rule. So it will be this limit h tends to 0, 3 by 2. Now this is 4 to the power h log 4 minus 1 upon, this is 1 by 3, 8 plus h to the power minus 2 by 3 minus 1 by 2, 4 plus 3h to the power minus 1 by 2 into 3. Now we'll put h as 0. Now if we put h as 0, we'll get this as 3 by 2 into log 4 minus 1, and here it will be this 1 by 3, and then it will be 8 to the power minus 2 by 3, which is 1 by 4, and this is 4 to the power minus 1 by 2, so it will be this 3 by 4. Now we can write this as 3 by 2 log 4 by e, and here if we take LCM, it will be minus 8 by 12. Now this is 6 and this is minus 4 by 3. So this value will be minus 9 by 4 log 4 by e, and that is the answer to this limit. Now here the question is, find this limit, which is limit x tends to 3 pi by 4 1 plus cube root of 10x upon 1 minus 2 cos square x. Now what we'll do is, we'll rationalize it using x to the power 2 by 3 minus 10x to the power 1 by 3 plus 1, and here also it will be 10x to the power 2 by 3 minus 10x to the power 1 by 3 plus 1. So we write this as, this is limit x tends to 3 pi by 4, and here will be 1 plus 10x and this is 1 minus 2 cos square x, which is minus cos 2x. And we know that minus cos 2x is 1 minus 10 square x upon 1 plus 10 square x. And here it will be 1 upon 10x to the power 2 by 3 minus 10x to the power 1 by 3 plus 1. Now 1 plus 10x will cancel. So we can write this as limit x tends to 3 pi by 4 1 plus 10 square x, and this is minus, and here will be 1 minus 10x and then 10x to the power 2 by 3 minus 10x to the power 1 by 3 plus 1. Now if we put x as 3 pi by 4, we'll get this as 1 plus minus 1 square, and here will be 1 minus minus 1 2, and this will be 6. So value of this limit will be simply minus 1 by 3. Now the question is, we need to solve this limit, which is limit x tends to 0 8 upon x to the power 8, and here it is 1 minus cos x square by 2 minus cos x square by 4 plus cos x square by 2 into cos x square by 4. Now we can take cos x square by 4 common, then we can factorize this as limit x tends to 0 8 upon x to the power 8, and here will be 1 minus cos x square by 2 into 1 minus cos x square by 4. Now we can make them as standard limits. So here will be 1 minus cos x upon x square. So it should be x to the power 4 upon 4. And here it will be x to the power 4 upon 16. And since we have divided it, we have to multiply them. So it will be x to the power 4 upon 4 and x to the power 4 upon 16. Now x to the power 8 will cancel. Now this is 2. Now the standard limit 1 minus cos x upon x square, it is 1 by 2, and this also is 1 by 2. So this value will be simply 1 by 32, and that is the answer to this question. Now here the question is, we need to find this limit x tends to 0 tan inverse a upon x square. Now if we put x tends to 0, it will be this a into infinite, and a into infinite can be positive and it can also be negative. So we have three cases. Case 1, if the value of a is 0, then in that case it will be simply this tan inverse 0, which is 0. If a is greater than 0, then this limit x tends to 0 tan inverse a upon x square will be equals to tan inverse infinite, and tan inverse infinite is pi by 2. And if a is less than 0, then this limit x tends to 0 tan inverse a upon x square will be tan inverse of minus infinite, which is minus pi by 2. So this limit will have three values depending on the value of a. If a is 0, then it will be 0. If a is positive, then it will be pi by 2. And if a is negative, then it will be minus pi by 2. Now it says, plot the graph of this function fx, which is limit t tends to 0 to x upon pi into tan inverse x upon t square. Now this limit x upon t square is same as limit tan inverse a upon x square. So we'll consider three cases. Case 1, if x is 0, when x is 0, this expression is 0. In that case, value of fx will be simply 0. Now if x is greater than 0, then the value of this limit is pi by 2. So we can write this function fx as 2x upon pi into pi by 2. That means then it will be this x, and third, if x is less than 0, we'll get this fx as 2x upon pi, and then it will be this minus pi by 2, which is minus x. So basically this function fx is nothing but mod x, and the graph of mod x is this V-shaped graph. This is x and this is minus x. Now the question is, find the sum of an infinite GP whose first term is this limit, whose first term is this limit x tends to 0, 10x minus sin x upon sin cube x. Now if we take 10x common, we can write this as limit x tends to 0, 10x into 1 minus cos x upon sin cube x. Now if we multiply and divide it with x cube, we can write this as limit x tends to 0, 10x upon x, 1 minus cos x upon x square, and then it will be this x cube upon sin cube x. Now this is 1, this is 1 by 2, and this is 1. That means the first term of this geometric series is 1 by 2. So value of a is 1 by 2. Now we need to find the value of its common ratio, which is r. Now r is this limit, which is limit x tends to 1, 1 minus under root x upon cos inverse x whole square. Now here we use substitution. We let x as cos theta. Now if we take x as cos theta, then we can write this as this limit x tends to 1, 1 minus under root of cos theta upon cos inverse of cos theta is theta, so it will be this theta square. We'll write this as limit x tends to 1, and if we rationalize, we will write 1 minus cos theta upon theta square into under root of 1 plus cos theta. Now this is 1 by 2 and it is also 2. So value of r is 1 by 4. So once we have a and r, we can find sum of this infinite GP. Sum of this infinite GP will be a upon 1 minus r. Value of a is 1 by 2 and value of r is 1 by 4. So this value will be simply 2 by 3, and that is the answer to this question. Now for this question, we are given two functions fx and gx, and we need to find left hand limit and right hand limit of g of fx at x equals 0, and hence find this limit x tends to 0, g of fx. Now if we look at left hand limit, now left hand limit at x equals to 0 is x tends to 0 negative. Now x tends to 0 negative means x is less than 0, and if x is less than 0, then fx is going to take this definition. So it'll go to 2 minus x. Now since x is negative and it is 2 minus some negative number, this f0 negative, it will be greater than 2. So it'll take the value 2 positive. And when fx is greater than 2, then gx is going to take this definition. So this plus 2 will go to x minus 5, and 2 minus 5 is minus 3. So its left hand limit will be minus 3. Now if we look at its right hand limit, which is x tends to 0 positive, when x is greater than 0, it will go to x upon sin x. Now we know that sin x is less than x. That means x upon sin x, it is greater than 1. So basically this is 1 positive. And if it is greater than 1, then it will go to this definition, which is x square minus 2x minus 2. Now if we put x as 1, it will be 1 minus 4, which again is minus 3. Since both left hand limit and right hand limit, they exist and they are same, value of this limit is minus 3. Now here we are given a recursive relation which is Pn, and it is a Pn minus 1 minus 1, and let P1 be a to the power x minus 1. Now if we find Pn at 0, then it will be P10 is e to the power 0 minus 1, 0. And if we put P1 as 0, then P2 will be e to the power 0 minus 1, 0. So that's how we'll get all these P1, P2, Pn as 0. So Pn 0 will be 0. So you have to find this limit. X tends to 0. Pn upon x will be 0 upon 0 form. And if it is 0 upon 0 form, we can use L'Hopital's rule. So it will be equal to d by dx of Pn upon 1. Now we differentiate Pn, it will be this limit x tends to 0. Now this is a Pn minus 1 log a into derivative of Pn minus 1, and derivative of Pn minus 1 will be a P n minus 2 log a, and will continue up to this last one, which is a to the power x into log a. Now if we put x as 0, we know that all P1, P2, Pn, they are 0. So a to the power 0 is 1. So value of this limit will be log of a to the power n, and that is the answer to this question. Now here the question is, we need to find this limit x tends to minus infinite, and this is 3x to the power 4 plus 2x square sine 1 by x plus mod of x cube plus 5 upon mod x cube plus mod of x square plus mod of x plus 1. Now since x is minus infinite, that means x is less than 0, and when x is less than 0, then mod of x is simply minus x. So we write this as limit x tends to minus infinite, and this is 3x to the power 4 plus 2x square sine 1 by x minus x cube plus 5 upon minus x cube plus x square minus x plus 1. Now we'll divide everything with x cube. So we can write this as limit x tends to minus infinite, and here will be 3x plus 2 upon x sine 1 by x minus 1 plus 5 upon x cube, and here will be minus 1 plus 1 upon x minus 1 upon x square plus 1 upon x cube. Now everything is sorted other than this x. So we'll multiply it with sine 1 by x. We can write this as limit x tends to minus infinite 3 into. Now we'll write this as sine 1 by x into x, and which can also be written as 1 by x and plus 2 by x sine 1 by x minus 1 plus 5 upon x cube divided by minus 1 plus 1 by x minus 1 upon x square plus 1 upon x cube. Now when x tends to infinite, sin x is 0, so it is 0 upon 0 form. So this limit, it is 1, it will be 0. This is minus 1, this is 0, all of them, they will be 0. So this limit will be 3 minus 1 upon minus 1, which is minus 2. So answer to this limit is minus 2. Now in this question, we are given fx and gx, and we need to find tan inverse of g1 negative. Now if we look at g1 negative, that means it will be equal to 2 f1 negative plus 1 upon 3 f1 negative plus 1, and when x is less than 1, it is this log. So it will be 2 to the power log cosec pi x plus 1 upon 3 to the power log cosec pi x plus 1 when this limit x tends to 1 negative. Now if we put x is 1, we know that cosec pi is infinite and will be this log infinite. So what we'll do is we'll divide everything with 3 to the power log cosec pi x. So it will be this limit x tends to 1 negative and it will be this 2 by 3 log cosec pi x plus 1 upon 3 to the power log cosec pi x, and here will be 1 plus 1 upon 3 to the power log cosec pi x. Now when log cosec pi x tends to infinite, we know that a to the power infinite is 0 if a lies between 0 and 1. So this limit will be 0. This expression 1 upon infinite will be 0. This also will be 0. So it will be 0 upon 1. So value of g1 negative is 0, and if we find tan inverse g1 negative, it will be tan inverse 0, and tan inverse 0 is simply 0. So answer to this first part is 0. Now in the second part it says secant inverse of g1 positive. Now if we look at g1 positive, it will be 2f1 positive plus 1 and 3f1 positive plus 1. Now when x is greater than 1, fx is log sine 2x pi. So it will be this limit x tends to 1 positive 2 to the power of log sine 2 pi x plus 1, and here will be this 3 to the power log sine 2 pi x plus 1. Now when x tends to 1, sine 2 pi is 0 and log 0 is minus infinite, and we know that 2 to the power of minus infinite will be 0 and 3 to the power minus infinite will also be 0. So this value, it is equal to 1. Now it says we need to find value of secant inverse of g1 positive. So secant inverse of 1 is also 0. This value is also 0. Now here the question is we need to find this limit x tends to 0, 1 plus x to the power 1 by x upon e whole to the power 1 by x. Now if we take this limit, 1 plus x to the power 1 by x is e upon e is 1, and 1 upon x will be infinite. So it is 1 to the power infinite form, and we know that there is this shortcut limit x tends to 0 fx to the power gx, and if it is of the form 1 to the power infinite, we can write this as e to the power this limit x tends to 0 gx into fx minus 1. So we write this as e to the power limit x tends to 0, and gx in this case is 1 by x, and then it will be 1 plus x to the power 1 by x minus e upon e. Now we can write this as this limit x tends to 0 1 by x. We'll use the expansion of 1 plus x to the power 1 by x. It is e minus ex by 2 minus e upon e. Now this e and e will cancel, ex will also cancel, and when we put x as 0, higher powers will cancel. So value of this limit will be e to the power minus 1 by 2. Now here the question is, we need to solve this limit x tends to 0 sine square pi upon 2 minus ax into secant square pi upon 2 minus bx. Now first we'll check its form. If we put x as 0, sine pi by 2 and sine pi by 2 is 1, and secant pi by 2 is infinite, so it is 1 to the power infinite form. We'll directly use the shortcut, so it will be this limit x tends to 0, and then it will be this secant square pi upon 2 minus bx into sine square pi upon 2 minus ax minus 1. Now sine square theta minus 1 is minus cos square theta, and we let the secant in terms of cos as well. So it will be this e to the power minus, and then this limit x tends to 0 cos square pi upon 2 minus ax upon cos square pi upon 2 minus bx. Now x square, it is a continuous function, so we can take this limit inside. So we can write this e to the power minus, and then this limit x tends to 0 cos pi upon 2 minus ax upon cos pi upon 2 minus bx whole square. Now if we look at this limit, this is cos pi by 2, which is 0, and denominator also it is cos pi by 2, so it will again be 0, so it is 0.0 form. Now we can use L'Hopital's rule. Now if we use L'Hopital's rule, we can write e to the power minus, and then it will be this limit x tends to 0. Now differentiation of cos is minus sine, so it will be this minus sine pi upon 2 minus ax, and then it will be this minus pi upon 2 minus ax whole square into minus a, and the denominator will be minus sine pi upon 2 minus bx, and then minus pi upon 2 minus bx whole square, and then it will be this minus b whole square. Now if we put this limit, sine pi by 2 is 1. Now minus pi and minus pi will cancel. This minus and minus will also cancel. Now if we put x as 0, this will be this 4, which will cancel. So answer to this limit will be simply e to the power minus a square upon b square. Now here the question is limit x tends to infinite x square sine log under root cos pi x. Now what we'll do is we'll let x as 1 by t, so it will be this limit t tends to 0 positive, and then it will be 1 minus t square sine, we'll take this power out, so it will be this 1 by 2 log cos pi t. Now if we put t as 0, now it will be this cos 0 is 1, log 1 is 0, so it will be this sine 0, which is 0.0 form. Now we use L'Hopital's rule, so we can write limit t tends to 0 positive. Now this is cos 1 by 2 log cos pi t into 1 by 2, and then 1 upon cos pi t, and then it will be this minus sin pi t into pi divided by 2t. Now we multiply and divide with pi also. Now this is cos 0 is 1. Now this also is cos 0, so it will be this 1, and then sin pi t upon pi t, when t tends to 0, it is also 1. So value of this limit will be minus pi square upon 4. Now here the question is, we need to find this limit x tends to infinite cos 2 pi x upon 1 plus x to the power a whole to the power x square if a belongs to R. Now first we'll check its form. Now this is x upon 1 plus x. When x tends to infinite, it will be 1. Now cos 2 pi is 1, and 1 to the power x square is 1 to the power infinite. So it is 1 to the power infinite form. That means we are going to use this shortcut directly. So it will be this e to the power, and then this limit x tends to infinite, x square into cos 2 pi. Now we'll actually write this as 1 plus 1 upon x to the power minus a, and then minus 1. Now here we'll use binomial expansion of 1 plus x to the power minus n. So it will be this e, and then this limit x tends to infinite, and then x square, and we can write this as cos 2 pi 1 minus a upon x, and then it will be minus a minus 1. So it will be this a into a plus 1 upon 2 1 by x square, and plus higher power of x, and then minus 1. Now cos 2 pi minus theta is cos theta. So we can write this as e to the power limit x tends to infinite, and we'll take minus common. So it will be this x square 1 minus cos 2 pi a upon x plus other terms. Now we'll rewrite this as e to the power limit x tends to infinite minus x square 1 minus cos 2 pi a upon x. Now we'll multiply and divide everything with 4 pi square, and then a upon x whole square. Now we have to multiply it also. Then it will be this 4 pi square a upon x whole square. Now this becomes a standard limit, which is 1 by 2. So we can write this as e to the power, and then this limit x tends to infinite minus 1 by 2 into x square into 4 pi square a upon x a plus 1 upon x square whole square. Now we multiply this x square, we'll get this a square. So it will be this e to the power minus 2 pi square into a square, and that is the answer to this limit. Now here the question is, we are given this limit x tends to infinite a1 to the power 1 by x plus a2 to the power 1 by x up to an to the power 1 by x whole divided by n to the power nx. Now if we put x is infinite, a to the power 0 is 1, a2 to the power 0 is also 1. So it will be 1 plus 1 plus 1 n times, n upon n is 1, and nx is infinite. So it is 1 to the power infinite form. Now we can write this as e to the power this limit x tends to infinite nx into a1 to the power 1 upon x plus a2 to the power 1 upon x an to the power 1 upon x whole divided by n, and then minus 1. Now we take this LCM, then we can write e to the power limit x tends to infinite nx, and here it will be this a1 to the power x plus a2 to the power 1 by x plus an to the power 1 by x minus n upon n. Now this n and n will cancel. Now we'll write this n as minus 1 minus 1 minus 1 n times, and we'll write this x as 1 by x. So it will be this e to the power limit x tends to infinite. It will be a1 to the power 1 by x minus 1 upon 1 by x plus a2 to the power 1 by x minus 1 upon 1 by x and up to an to the power 1 by x minus 1 upon 1 by x. Now this is standard limit. It will be log a1. Next one will be log a2 and log an. So it will be this e to the power log a1 plus log a2 plus log an, which is e to the power log a1 into a2 into an, which is a1 into a2 into an, this product. So answer to this limit is a1 into a2 up to an. And if we take a1 is 1, a2 is 2, an is n, then it will be 1 to the power 1 by x, 2 to the power 1 by x, n to the power 1 by x upon n to the power nx. Now it will be equal to a1 into a2 into a3 up to n. So it will be 1 into 2 into 3 up to n. In that case, answer to this limit will be factorial n. Now here the question is, we are given this function fx, we need to find right hand limit and left hand limit. Now if we find right hand limit, we are given that limit x tends to 0 positive, sine inverse 1 minus fraction part of x, cos inverse 1 minus fraction part x upon root 2 fraction part of x 1 minus fraction part of x. Now what we'll do is we'll let x as 0 plus h, and we also know that fractional part of h is simply h. So it will be this limit h tends to 0 positive, sine inverse 1 minus h, cos inverse 1 minus h upon root 2h, and it will be this 1 minus h. Now we don't have a problem with sine inverse because it will be sine inverse 1 pi by 2, and 1 minus h is also 1. So we'll put the values in these two. Then it will be sine inverse 1, which is pi by 2. And we also have this root 2. Now we are left with cos inverse 1 minus h upon under root h when this limit h tends to 0 positive. Now this is cos inverse 1, which is 0, and h is 0. So it is 0 upon 0 form. We'll use L'Hopital's rule. We'll write limit h tends to 0 positive pi upon 2 root 2. Now this is minus 1 upon under root of 1 minus h whole square, and then derivative of minus h is minus 1 divided by under root h is 1 upon 2 root h. Now minus and minus will be plus, so it will be this limit h tends to 0 pi upon 2 root 2, and we can write this as 2 root h, and here will be this under root of 2h minus h square. Now under root h will cancel, so we get this value as pi by 2. So for this function, its right hand limit is pi by 2. Now we will find its left hand limit. Now for left hand limit, we write limit x tends to 0 negative, sine inverse 1 minus fractional part of x, cos inverse 1 minus fraction part of x upon under root 2 fraction part of x and 1 minus fraction part of x. Now we let x as 0 minus h. Now we know that fraction part of minus h is 1 minus h. So now we can write this as this limit h tends to 0 positive, sine inverse 1 minus h, cos inverse 1 minus h, root 2 1 minus h, and this is 1 minus h, which is this limit h tends to 0 positive, sine inverse h into cos inverse h upon root 2 1 minus h and then h. Now sin inverse h upon h is 1. Cos inverse 0 is pi by 2 and this is root 2. So its left hand limit will be pi upon 2 root 2. So for this function, left hand limit is pi upon 2 root 2. Now since left hand limit and right hand limit, they are not equal. So this limit, it does not exist at x equals 0. Now the question is, find the value of a, b and c so that this limit is equal to 2. We are given that this limit x tends to 0, a into e to the power x minus b cos x plus c into e to the power minus x upon x sin x, and it will be equal to 2. Now we'll solve this question using series expansion. So we'll write this as limit x tends to 0. Now this is a. Now e to the power x is 1 plus x square upon 2 minus b. Now cos x is 1 minus x square upon 2 and plus c, e to the power minus x is 1 minus x plus x square upon 2 whole divided by x, and sin x is x minus x cube upon factorial 3, and this must be equal to 2. Now since x tends to 0 and answer is non-zero finite, that means minimum power of x in the numerator must be same as minimum power of x in the denominator. Now we know that minimum power of x in the denominator is 2. So in the numerator also, this minimum power, it must be 2. That means all the powers of x which are less than 2 must have coefficients 0. Now we look at this constant term. This constant term will be a minus b plus c will be 0. And if we look at coefficient of x will be a minus c and will also be 0. Now once we have eliminated all the lower degree terms, then answer to this limit will be coefficient of x square in the numerator upon coefficient of x square in the denominator. Now coefficient of x square in the numerator will be a by 2 plus b by 2 plus c by 2 upon 1 and will be equal to 2. So we get a plus b plus c equals 4. Now a equals c and b equals 2a. So we get 4a equals 4. That means a and c, they are 1 and value of b is 2. Now here the question is, we need to solve this limit x tends to a 1 upon a square minus x square whole square, and then we have a square plus x square upon ax minus 2 sine a pi by 2 into sine pi x by 2. Now we put x as a, it will be this 0 in the denominator and the numerator will be this 2 minus 2 0, so it is 0 upon 0 form. Now what we will do is we'll subtract 2 and we'll add 2. Now we can write this as limit x tends to a 1 upon a square minus x square whole square, and here it will be a square plus x square minus 2ax, which we can write a minus x whole square upon ax, and then plus we'll take this 2 common, it will be 1 minus sine a pi by 2 into sine pi by 2x. Now we'll multiply this a square minus x square whole square. So we can write this as this limit x tends to a, and it will be this a minus x whole square, and here will be this ax into, and we'll write this as a plus x whole square into a minus x whole square, and here it will be this 2 into 1 minus sine a pi by 2 into sine pi by 2x upon a minus x square into a plus x square. Now here a minus x whole square will cancel. Now we put x as a, we'll get this as a square plus 2a square. So there will be 1 upon 4 a to the power 4 and plus. Now here we don't have a problem with this a plus x. So it will be this 2a whole square. So it will be 4a square. We'll cancel this 2 with 4. So we can write this as 1 by 2 a square into this limit x tends to a 1 minus sine a pi by 2 into sine pi x by 2 upon a minus x whole square. It will be sine a pi by 2 whole square, and a is an odd integer. So it will be 1 minus 1 0. So it will be 0 upon 0 form. So now we can use L'Hopital's rule. Now if we use L'Hopital's rule, we can write 1 upon 4a to the power 4 plus 1 upon 2a square limit x tends to a, and this is minus sine a pi by 2, and this is cos pi by 2x into pi by 2 upon 2 into a minus x into minus 1. Now this minus and minus will cancel. Now this again is 0 upon 0 form, because cos odd multiple of pi by 2 is 0 and a minus a is also 0. So we now get this as 1 upon 4a to the power 4 plus 1 upon 2a square, and then this limit x tends to a sine a pi by 2. Now this is minus sine pi by 2x, and then it will be this pi by 2 square divided by 2 into minus 1. This minus and minus will cancel. Now we'll put x as a. If we put x as a, we'll get this as 1 upon 4a to the power 4 plus 1 upon 2a square, and here will be this sine a pi by 2 into sine a pi by 2, which is 1 into, now this is pi square by 4, and we have this 2 here. So it will be this 1 upon 4 a to the power 4 plus pi square by 16a square. So we'll take this LCM. So it will be this 16 a to the power 4, and then it will be 4 plus pi square into a square, and that is the answer to this limit. Now here the question is, this limit y tends to 0, limit x tends to infinite, e to the power x log 1 plus ay by x minus e to the power x log 1 plus by by x whole divided by y. Now we'll take this power in the log, then e and log will cancel. So we'll actually get this as limit y tends to 0, limit x tends to infinite, e and log they'll cancel, it'll be 1 plus ay by x whole to the power x minus 1 plus by x whole to the power x whole divided by y. Now first we'll solve this limit in x. Now we put x as infinite, it will be 1 to the power infinite form. So we can directly use this shortcut. So it will be this limit y tends to 0, and we'll write this as e to the power limit x tends to infinite x into fx minus 1, which is ay by x, and minus, in the same way we can write this as limit x tends to infinite x into by by x whole divided by y. Now x and x will cancel, we'll get this as limit y tends to 0 e to the power ay minus e to the power by upon y. Now this is 0 upon 0 form. We can write this as limit y tends to 0 e to the power ay into a minus e to the power by into b upon 1. So answer to this limit will be a minus b. Now the question is, let Sn be the sum of this series sin x plus sin 2x plus sin nx. Now basically angles are in AP with common difference of x. So what we'll do is we'll multiply and divide it with 2 sin x by 2. So it'll be this 2 sin x by 2 and then sin x plus sin 2x up to sin nx. Now we like this is 1 upon 2 sin x by 2 and will be 2 sin x by 2 into sin x, 2 sin x by 2 into sin 2x, 2 sin x by 2 into sin nx. Now will be 1 upon 2 sin x by 2. Now this is 2 sin A sin B. So it will be cos A minus B, which is cos x by 2 minus cos 3x by 2. Now here will be cos 3x by 2 minus cos pi x by 2. And in the end we'll have cos n minus 1 by 2x minus cos n plus 1 by 2x. Now all these terms, they'll cancel. So basically we'll get this Sn is 1 by 2 cot x by 2 minus cos n plus 1 by 2x upon sin x by 2. Now if we take this summation, r varies from 1 to n, SR will be this 1 by 2 n cot x by 2 and then minus this summation r varies from 1 to n cos r plus 1 by 2x upon sin x by 2. Now we need to find this limit n tends to infinite summation SR upon n. Now will be this limit n tends to infinite. Now here n and n will cancel. This 1 by 2 cot x by 2 and then minus this summation r varies from 1 to n cos r plus 1 by 2x upon sin x by 2. And the question it is given that x is unequal to 2k pi. That means this cos r plus 1 by 2 is not equal to 1. That means this cos r plus 1 by 2 is less than 1. So this summation, here we'll also have this n. This summation will be less than n and in the denominator we have n. So value of this limit when n tends to infinite will be 0. So answer to this question will be simply 1 by 2 cot x by 2. Now here the question is we need to solve this limit x tends to 0 log 1 plus x to the power 1 plus x upon x square minus 1 by x. Now we can also write this as this limit x tends to 0, 1 plus x log 1 plus x minus x upon x square. Now we'll use the expansion for log 1 plus x. So it will be this limit x tends to 0, 1 plus x, and then it will be x minus x square upon 2, and then minus x upon x square. Now we can write this as x minus x square upon 2 plus x square plus higher power of x minus x upon x square. Now this x and x will cancel. Now this minimum power in the numerator is same as minimum power in the denominator. So answer to this limit will be coefficient of x square in the numerator upon coefficient of x square in the denominator, which is 1 by 2. So answer to this limit is 1 by 2. Now we are given this expression Pn, which is 2 cube minus 1 upon 2 cube plus 1, 3 cube minus 1 upon 3 cube plus 1 up to n cube minus 1 upon n cube plus 1. Now it says we need to find this limit n tends to infinite Pn. Now we'll write this Pn as this product where r varies from 2 to n, and will be this r cube minus 1 upon r cube plus 1. Now we'll write this as this product r varies from 2 to n, and this is r minus 1 upon r plus 1, and here will be this r square plus r plus 1 upon r square minus r plus 1. So we'll split this product in two parts. So first part is r varies from 2 to n, r minus 1 upon r plus 1, and here will be this product from 2 to n, r square plus r plus 1 upon r square minus r plus 1. Now the difference between these two is 2. That means terms will cancel after 2 terms. So if we put r as 2, it will be this 1 by 3 and 2 by 4, 3 by 5, and it will go all the way up to n minus 2, n minus 1, and here will be this n and n plus 1. And here we'll have r square plus r plus 1 and r square minus r plus 1. Now if we look at this r square minus r plus 1, if we replace r with r plus 1, then it will be r plus 1 square minus r plus 1 plus 1. So it will be r square plus r plus 1, which is same as the numerator. So between this r and r plus 1, there is a difference of only 1. So terms will cancel after 1. So if we put r as 2, we'll get this as 4 plus 2, 6 plus 1, 7. 7 by 3. Now we put r as 3, it will be 9 plus 1, 10, 13. And then it will be 10 minus 3, 7. And in the end, we'll have n square plus n plus 1 upon n square minus n plus 1. Now here, terms will cancel after 2. So in the end, we'll have 2 upon n plus 1. And here, since the difference is 1, terms will cancel immediately. So here we'll have n square plus n plus 1 divided by 3. Now if we take this limit, n tends to infinite Pn, it will be simply coefficient of n square in the numerator and denominator, which is 2 by 3. And that is the answer to this question. Now here the question is, a circular arc of radius 1 subtends an angle of x radian. As shown in this figure, point C's intersection of two tangent lines at A and B Let Tx be the area of triangle ABC and Sx be the area of shaded region. Then we have to find Tx, Sx and this limit. Now radius is 1. If we draw a line here, this angle will be x by 2 and this is 90. And suppose this point is D. So this is A, B, C, and we have this triangle ABC. Now in this triangle OBD, we can write BD as 1 sine x by 2. That means value of AB is 2 sine x by 2. And in this triangle, this angle is pi by 2 minus x by 2. So once we have BD, we can find CD. So we can write BD upon CD will be equal to 10 pi by 2 minus x by 2, which is cot x by 2. So we can write CD as sine square x by 2 upon cos x by 2. Now once we have AB and CD, we can write this Tx, which is area of triangle ABC. So this Tx will be 1 by 2 into 2 sine x by 2 into sine square x by 2 upon cos x by 2. I'll cancel. So we'll get this as sine cube x by 2 upon cos x by 2. Now we'll find Sx, which is area of this shaded region. Now this Sx will be now area of this sector, which is 1 by 2 r square theta minus area of this triangle, which is 1 by 2 1 square sine x. So it will be this 1 by 2 x minus sine x. Now we need to find this limit Tx upon Sx as x tends to 0. Now this limit x tends to 0 Tx upon Sx will be this limit x tends to 0 sine cube x by 2 upon cos x by 2, and here it is x minus sine x and then into 2. Now we'll solve this question using series expansion. Now it will be this limit x tends to 0 and here will be this x by 2 whole cube upon factorial 3 into 2. Here it is 1 minus x by 2 whole square upon factorial 2, and here will be this x minus x cube upon factorial 3. Now x and x will cancel, it will be this plus, and we have this power 3 here. Now minimum power of x in the numerator is 3 and minimum power of x in the denominator is also 3. So answer to this limit is coefficient of x cube. Now coefficient of x cube in the numerator will be this 2 into and then x upon 2 whole cube. So it will be this 1 by 8 and here it will be 1 into 1 by 6, which is 6 by 4, and that is 3 by 2. So this limiting value is 3 by 2 and that is the answer to this question. Now here this question is this limit x tends to infinite under root x upon under root x plus under root x plus under root x. Now highest power of x in the numerator is 1 by 2 and highest power of x in the denominator is also 1 by 2. So we'll divide everything with under root x. So we'll write this as limit x tends to infinite and this is 1 upon and will be this 1 plus and under root of 1 by x will be under root of x cube. Now if we take x as infinite, it will be 0. it'll be 0. So answer to this limit is simply 1. And if we look at this b, then it'll be this limit x tends to infinite under root of x plus under root of x plus under root of x minus under root of x. Now we rationalize it, we can write this as limit x tends to infinite, and it will be x plus under root of x plus under root of x minus x upon under root of x plus under root of x plus under root of x plus under root of x. Now highest power of x in the numerator is 1 by 2 and highest power of x in the denominator is also 1 by 2. Now coefficient of x to the power 1 by 2 is 1 and here it is 1 plus 1 2. So answer to this limit is 1 by 2. Now in this question we given this f n theta and it is given as this product r varies from 1 to n 1 minus tan square theta upon 2 to the power r. Now what we'll do is we'll multiply and divide it with 2 tan theta upon 2 to the power r. So it will be this product r varies from 1 to n. Now this is tan 2 theta. So it will be this 1 upon tan 2 theta 2 to the power r, and this is 2 tan theta 2 to the power r, which is this product r varies from 1 to n 2 into tan theta upon 2 to the power r upon tan theta upon 2 to the power of r minus 1. Now we'll expand this product. Now if we put r from 1 to n, it will be 2 into 2 into 2 n times. So that will be simply 2 to the power n. Now here if we put r as 1, it will be this tan theta by 2 upon tan theta. Now for r equals to, it will be tan theta upon 2 square upon tan theta upon 2, and we will continue up to tan theta upon 2 to the power n upon tan theta and 2 to the power of n minus 1. Now terms cancel only after first one. So all these they will cancel. So we'll get this fn theta as 2 to the power n tan theta upon 2 to the power n by tan theta. Now we need to find this limit n tends to infinite fn theta. So this limit n tends to infinite fn theta will be this limit n tends to infinite, and we'll rearrange all this a bit. So we'll write this as 1 upon tan theta. This is nothing to do with n, and it'll be this tan theta upon 2 to the power n, and we'll take this 2 to the power n in the denominator. So it'll be 1 upon 2 to the power n. We'll multiply and divide everything with theta. Now when n tends to infinite, 1 upon 2 to the power n tends to 0. So this is 0 upon 0 form. So tan 0 upon 0 is 1. So answer to this limit is simply theta upon tan theta. Now the question is limit x tends to 0 to tan x minus sin x minus x cube upon x to the power 5. Now we'll use series expansion in this. So this is limit x tends to 0, and this is 2, and this is x plus x cube by 3 plus 2 by 15 x to the power 5 minus, now sin x is x minus x cube upon 6 plus x to the power 5 upon 120, and it will be this minus x cube whole divided by x to the power 5. Now x and x will cancel. We'll get this as limit x tends to 0, and this is 2, and it will be this x cube 1 by 3 plus 1 by 6 and plus x5, and it will be this 2 by 15 minus 1 by 120, and then minus x cube upon x to the power 5. Now this is limit x tends to 0, and this is 2x cube, and it will be this 1 by 2 and plus x to the power 5 will be this 15 upon 120, and then minus x cube. Now we will take this 2 inside. Now this x cube will cancel. So the lowest power of x in the numerator and denominator, it is x to the power 5. So answer to this limit is 15 by 60, which is 1 by 4. Now here this first question is find the value of a and b if this limit x tends to infinite, x square plus 1 upon x plus 1 minus ax minus b is equal to 0. Now we can write this as limit x tends to infinite. This is x square plus 1 minus ax plus b into x plus 1 upon x plus 1, and it should be 0. Now this is limit x tends to infinite. Now it will be 1 minus ax square and then minus a plus bx plus 1 minus b upon x plus 1 equals 0. Now since it is non-infinite, that means power in the denominator and power in the numerator should be same, or power in the numerator should be less. That means this coefficient of x square, it must be 0. So from here we get 1 minus a equals 0. That is value of a, it must be 1. Now if a is 1, then both numerator and denominator have highest power x. So in this case, value of this limit will be minus a plus b upon 1 equals 0. Then value of b is minus 1. So for the first part, value of a is 1 and value of b is minus 1. Now we look at the second limit. The second limit is limit x tends to minus infinite under root of x square minus x plus 1 minus ax minus b, and it must be equal to 0. Now first we'll check its form. Now this is infinity and then minus a into minus infinite. Now if a is greater than 0, in that case this limit will be infinite, which is non-indeterminate form. So for this limit to have an answer 0, clearly a must be less than 0. So we are looking for the value of a, which is negative. Now we can write this as limit x tends to minus infinite. Now we'll rationalize it. So we'll write this as x square minus x plus 1 minus ax plus b whole square whole divided by under root of x square minus x plus 1 and plus ax plus b, and it should be equal to 0. Now we write this as limit x tends to minus infinite, and here will be this 1 minus a square x square and then plus minus 1 minus 2abx and plus 1 minus b square upon under root of x square minus x plus 1 plus ax plus b, and it must be equal to 0. Now in the denominator, highest power is 1. So in the numerator also, highest power should be 1 or less for this limit to be 0. That means coefficient of x square, it should be 0. From here we will get the value of a as either plus 1 or minus 1. But we already know that a cannot be positive. So the only value of a possible in this case is a equals minus 1. Now once there is no x square, then answer to this limit will be coefficient of x. Now coefficient of x in the numerator will be minus 1 minus 2ab upon, now here if we take x square common, then it will be this mod x 1 minus 1 upon x, and this mod x is minus 1, so it will be this minus 1 plus a, and it must be 0. Though in this question this minus doesn't make a difference, but then most of the people, they make a mistake when they go to write this coefficient of x in the denominator. Now from here we can write 2ab, it is equal to minus 1, then value of b is equal to 1 by 2. So for the second one, a is minus 1 and b is 1 by 2. Now here the question is, we need to solve this limit, which is limit x tends to 0 sine pi into cos square x upon x square. Now sine pi is 0, so this is 0 upon 0 form. We'll use L'Hopital's rule, so it will be this limit x tends to 0, and then it will be this cos pi cos square x, and then pi into 2 cos x, and then minus sin x whole divided by 2x. Now this 2 and 2 will cancel. Now sin x upon x, when x tends to 0, it is 1. Now when we put x as 0, this is cos pi is minus 1, and then we have this pi, cos 0 is 1, and then we have this minus 1. So answer to this limit is pi, and that's your option B. Now here the question is, this limit x tends to 0 a to the power 10x minus a to the power sin x upon 10x minus sin x when a is greater than 0. Now we'll take a to the power sin x common, so we can write limit x tends to 0, and will be this a to the power sin x, and here we get a to the power 10x minus sin x minus 1 upon 10x minus sin x. Now a to the power 0, it is 1, and then this is 10x minus sin x, which is 0. So this is a to the power 0 minus 1 upon 0, which is standard limit ln a. So answer to this question is simply ln a. Now here the question is the integer n for which this limit is finite non-zero number. Now this is limit x tends to 0. That means we are looking for lowest power of x in the numerator and the denominator. Now this is cos x minus 1, and this is cos x minus e to the power x upon x to the power n. Now this is limit x tends to 0, and this is 1 minus x square upon factorial 2 minus 1, and here it is 1 minus x square upon factorial 2, and this is minus 1 minus x minus x square upon factorial 2 whole divided by x to the power n. Now 1 will cancel, and here also this 1 will cancel. Now for this limit to have a finite non-zero answer, minimum power of x in the numerator must be same as minimum power of x in the denominator, as this is limit x tends to 0. Now minimum power in the numerator will be this x square gets multiplied with this x. So in the numerator, smallest power of x is 3. So in the numerator also, smallest power must be 3. That is the value of n, it should be 3, and that's your option C. Now here the question is, we are given that this limit x tends to 0 sin nx into this a minus n into nx minus 10x upon x square, it is equal to 0 for n greater than 0. Now we can write this as limit x tends to 0, and this is sin nx upon x, and here we'll take one of the x with this, so it will be this a minus n into n minus 10x upon x, and it should be equal to 0. Here we'll multiply and divide with n. Now this is standard limit 1, 10x upon x is also standard limit 1, so it will be this n into a minus n into n minus 1 equals 0. So from here we can write a minus n equals 1 by n, or the value of a must be n plus 1 upon n, and that's your option C. Now here the question is, we need to find this limit n tends to infinite, and then it'll be this 2 upon pi n plus 1 cos inverse 1 by n minus n. Now what we'll do is we'll take these terms of n together, then we can write this as limit n tends to infinite, and this is n, and it will be 2 upon pi cos inverse 1 by n minus 1 plus 2 upon pi cos inverse minus 1 by n. Now here we'll take 2 upon pi also common, so we can write this as limit n tends to infinite, and here will be 2n upon pi, and this is cos inverse 1 by n minus pi by 2, and this is 2 upon pi cos inverse 1 by n. Now pi by 2 minus cos inverse n is sin inverse 1 by n, so we can write this as limit n tends to infinite and minus sin inverse 1 by n, and this is 2 upon pi, and we'll take this n in the denominator, so it will be 1 by n plus 2 upon pi cos inverse 1 by n. Now as n tends to infinite, 1 upon n tends to 0, so this is sin inverse 0 upon 0, which is standard limit 1, so it will be this minus 2 upon pi, and here it will be this cos inverse 0, and cos inverse 0 is pi by 2, so it will be 2 upon pi into pi by 2. So answer to this limit will be minus 2 upon pi plus 1. Now here the question is, if alpha and beta are the roots of this quadratic equation, then solve this limit. Now this is limit x tends to alpha and 1 minus cos ax square plus bx plus c upon x minus alpha whole square. Now if we put x as alpha, it will be this cos 0 is 1, so this is 0 upon 0 form, so we'll convert it in standard limit, so we can write limit x tends to alpha, and this is 1 minus cos ax square plus bx plus c upon, so this is 1 minus cos x upon x square, so it will be this ax square plus bx plus c whole square into this ax square plus bx plus c whole square divided by x minus alpha square. Now this standard limit, it is 1 by 2, so we can write this as limit x tends to alpha 1 by 2, and we can write this quadratic equation as a x minus alpha into x minus beta whole square upon x minus alpha square. Now x minus alpha square will cancel, so answer to this limit will be 1 by 2 a square into alpha minus beta whole square, and that's your option C. Now here the question is, ABC is an isosceles triangle inscribed in the circle of radius r. So we have this circle of radius r, and then we have an isosceles triangle inscribed in it. So this is A, B, C, with AB equals AC. If h is the altitude from A to BC, so this altitude from A to BC, it is of the length h, and P is the perimeter of ABC. Now we need to find this limit h tends to 0, delta upon P cube, where delta is area of this triangle. Now radius of this circle is r, so this is r, this is also r, and this side will be h minus r, so this is h minus r. Now from this we can write BD, and BD will be under root of r square minus h minus r whole square, so it will be this under root of 2hr minus h square. Now once we have BD, we can write AB using Pythagoras theorem. This AB square will be AD square, which is h square plus BD square, which is 2hr minus h square. So length of AB, it will be under root of 2hr. Now once we have all this, we can write perimeter of this triangle. So its perimeter will be 2 times AB, which is root 2hr plus 2 times BD, which is 2 times under root of 2hr minus h square. Now we'll also write area of this triangle. Now area of this triangle will be simply 1 by 2 h into 2 times BD. So it will be 2 times under root of 2hr minus h square. Now this 2 and 2 will cancel. Now we need to find this limit h tends to 0 delta upon PQ. So it will be this limit h tends to 0 delta upon PQ. So it will be this limit h tends to 0. Now delta is h into 2hr minus h square upon, and PQ will be 2 root 2hr plus 2 into 2hr minus h square whole cube. Now in the numerator, we'll take this h common from the root, so it will be this limit h tends to 0, and then it will be this h to the power 3 by 2 under root of 2r minus h, and here we'll take under root h common, so it will be h to the power 3 by 2, and we are left with 2 root 2r plus 2 into root 2r minus h whole cube. Now this will cancel. If we put this limit h tends to 0, we'll get this as under root 2r upon, now this is 2 root 2r plus 2 root 2r. So it will be 4 root 2r, and 4 root 2r cube will be 64 into 2 root 2 r root r. Now root 2r will cancel. So this value will be 1 by 128r. And that's your option C. Now here the question is, if this box represents greatest linear function, then we need to find this limit, which is limit n tends to infinite 1 upon n to the power 4, and then this greatest linear function of 1 cube x plus 2 cube x up to n cube x. Now we know that greatest linear function of x is x minus fractional part of x. So we'll write this as limit n tends to infinite 1 cube x minus fractional part of 1 cube x plus 2 cube x minus fractional part of 2 cube x up to n cube x minus fractional part of n cube x whole divided by n to the power 4. Now we'll separate these two limits. So we'll write them as limit n tends to infinite, and first one will be 1 cube plus 2 cube up to n cube into x upon n to the power 4, and then minus this limit n tends to infinite, and this is fractional part of 1 cube x, fractional part of 2 cube x plus fractional part of n cube x upon n to the power 4. Now we know that any fractional part function will always lie between 0 and 1. So the maximally this numerator can take is n, and n upon n to the power 4 will always be 0. So this second limit will be 0. So now we can write this as limit n tends to infinite. Now this is n plus 1 upon 2 whole square into x upon n to the power 4. Now since this is infinite limit, we are looking for highest power of n. Now highest power of n, the numerator is n to the power 4, and the denominator also it is n to the power 4. Now here its coefficient will be x by 4, and that's your option D. Now here the question is, we need to find this limit x tends to pi by 2 sin x upon cos inverse the greatest integral function of 1 by 4 into 3 sin x minus sin 3x, where this box represents greatest integral function. Now if we look at this 1 by 4, 3 sin x, now minus sin 3x is 3 sin x minus 4 sin cube x. Now this 3 sin x will cancel, this 4 will also cancel, so this value will be simply sin cube x. So we can write this limit as limit x tends to pi by 2 sin x upon cos inverse greatest integral function of sin cube x. Now when x tends to pi by 2, sin cube x tends to 1, but it is still less than 1 because it will be 1 only at pi by 2. So within the vicinity of pi by 2, it will be less than 1. So this sin cube x, it is nearly 1 but less than 1. In that case, greatest integral function of sin cube x will be nothing but 0. So it will be this sin pi by 2 1, and then cos inverse 0, and cos inverse 0 is pi by 2. So answer to this limit will be 2 upon pi, and that's your option A. Now here the question is, we need to find limiting value of this function fx, limit x tends to pi by 4, and it is 2 root 2 minus cos x plus sin x whole cube divided by 1 minus sin 2x. Now what we'll do is, we'll take this 2 root 2 common, then we can write limit x tends to pi by 4, it is 2 root 2, and it will be 1 minus, and this is 1 by root 2 cos x plus 1 by root 2 sin x whole cube upon 1 minus sin 2x. Now this is cos A cos B plus sin A sin B, so it will be cos A minus B. So we can write this as limit x tends to pi by 4, 2 root 2 1 minus cos pi by 4 minus x whole cube upon 1 minus sin 2x. Now what we'll do is, we'll let x as pi by 4 minus h. So it will be this limit h tends to 0, 2 root 2 1 minus cos cube h, this part it should be this cos cube, and then it will be 1 minus sin 2 into pi by 4 minus h, will be sin pi by 2 minus 2h, that will be cos 2h. Now we can write this as limit h tends to 0, and it will be this 2 root 2 1 minus cos h 1 plus cos square h plus cos h upon 1 minus cos 2h. Now for this, we'll multiply and divide everything with h square, and for this, we'll multiply and divide it with 2h square. Now this is 1 by 2. This also is 1 by 2, which will cancel. Now h square and h square will also cancel. So we'll get this limit as 2 root 2, and this is 1 plus 1 plus 1. It will be 3 divided by 4. So this value will be 3 by root 2. And that's your option D. Now here the question is, we need to find this limit. N tends to infinite. 1 square n plus 2 square n minus 1 plus 3 square n minus 2 up to n square 1 upon 1 cube plus 2 cube up to n cube. Now first what we'll do is we'll simplify this series in the numerator. So we'll write this as 1 square n plus 2 square n minus 1, 3 square n minus 2 up to n square 1, and we'll write this as this summation r varies from 1 to n r square, and then it will be n minus r plus 1. Now this is n plus 1 into this summation r square minus summation r cube. Now we'll solve this limit. So this limit, say L, will be this limit n tends to infinite n plus 1 summation r square minus summation r cube upon summation r cube. Now it will be this limit n tends to infinite n plus 1 summation r square upon summation r cube minus 1. Now this is limit n tends to infinite n plus 1. Now summation r square is n plus 1 to n plus 1 divided by 6, and summation r cube is n plus 1 upon 2 whole square and then minus 1. Now this n plus 1 will cancel once, and this 2 will also cancel once. So we'll get this as limit n tends to infinite 2 n plus 1 into 2n plus 1 divided by 3 n into n plus 1 minus 1. Now this n plus 1 will also cancel. So answer to this question will be 4 upon 3 minus 1, which is 1 by 3. And that's your option A. Now we are given this function f(x), which is defined in terms of this limit n tends to infinite 1 upon 1 plus n into sine square pi x. Now we know that sine n pi is 0. So if x is an integer, then in that case sine pi x will be 0, and for all such cases value of fx will be 1. Now when x is not an integer, then in that case sine pi x, it is unequal to 0, and if it is unequal to 0, then we put this limit n tends to infinite, it will be 1 upon infinite, which is 0. So this function will take the value 0. So this function fx is such that it is 1 if x is an integer, and it is 0 if x is not an integer. Now the first one is range of f is a singleton set. No, it has two values, 1 and 0. So option A is incorrect. F is continuous on R, not possible. C is f is discontinuous for all x belongs to z. Yes, that's true. It is discontinuous for all x belongs to I. And D is f is discontinuous for some x belongs to R. So if it is single option, then I think better one is C, but then this D is also correct because this function fx is discontinuous for some values of r, and all those values, they are integral values. Now the question is, we need to find this limit x tends to 1 by root 2 x minus cos of sin inverse x and 1 minus tan of sin inverse x. Now one of the ways of solving this problem is we let sin inverse x as theta. So x will be sin theta. So we can write this as limit theta tends to pi by 4 sin theta minus cos theta upon 1 minus tan theta. Now tan theta is cos theta minus sin theta. So will be this limit theta tends to pi by 4 and then minus cos theta, which is minus 1 by root 2, and that's your option B. Now here the question is, this limit x tends to infinite cot inverse under root of x plus 1 minus under root x, and it will be this secant inverse 2x plus 1 upon x minus 1 whole to the power x. Now we write this as limit x tends to infinite. When we rationalize this, we can write this as cot inverse, and it will be 1 upon x plus 1 plus under root x, and this one is secant inverse 2 plus 3 upon x minus 1 to the power x. Now this is cot inverse 0, and here it will be this secant inverse 2 to the power infinite. Now cot inverse 0 is pi by 2, and secant inverse infinite is also pi by 2. So value of this limit is 1, and that's your option A. Now here the question is, we are given this function fx as log x square plus e to the power x upon log x to the power 4 plus e to the power 2x. And this limit x tends to infinite fx is L and x tends to minus infinite fx is M. Then find the relationship between L and M. Now for L, it will be this limit x tends to infinite log x square plus e to the power x upon log x to the power 4 plus e to the power 2x, which is infinity upon infinity form. We'll use L'Hopital's rule, so it will be this limit x tends to infinite, and then we can write this as 1 upon x square plus e to the power x into 2x plus e to the power x, and here it will be 1 upon x to the power 4 plus e to the power 2x into 4x cube plus 2 e to the power 2x. Now we can write this as limit x tends to infinite 2x plus e to the power x upon x square plus e to the power x into x to the power 4 plus e to the power 2x upon 4x cube plus, and this is 2 e to the power 2x. Now here we'll divide everything with e to the power x, and here we'll divide everything with e to the power 2x. So we can write this as limit x tends to infinite 2 x upon e to the power x plus 1 x square upon e to the power x plus 1, and here it will be x to the power 4 upon e to the power 2x plus 1, and this is 4 x cube upon e to the power 2x plus 2. Now we know the standard result that this limit x tends to infinite x to the power n upon e to the power x, it is 0. And it is very easy to prove. This is infinity upon infinity form. So we'll keep using L'Hopital's rule. It will always be infinity upon infinity form. So if we differentiate this n times, we'll get this as factorial n upon e to the power x. Now this is factorial n upon infinite, and which is 0. So this limit will always take the value 0. So this is 0, this is 0, this is 0, this is 0. That means from here we can say value of L is simply 1 by 2. Now we'll find the value of M. Now for M, we have this limit x tends to minus infinite, and again we'll get this same differentiation will be 2x plus e to the power x upon x square plus e to the power x into x to the power 4 plus e to the power 2x upon 4x cube plus 2 into e to the power 2x. Now here this is x and x4, x to the power 5. Here it is x square and x cube, x to the power 5. So we'll divide everything with x to the power 5. So we can write limit x tends to minus finite. This is 2 plus e to the power x upon x, and here it will be 1 plus e to the power 2x upon x to the power 4, and this is 1 plus e to the power x upon x square, and here will be this 4 plus 2 e to the power 2x upon x cube. Now e to the power nx upon x to the power r, where limit x tends to minus infinite. E to the power minus infinite is 0, and 0 upon infinite is 0. So all these terms, they will be 0. So from here we'll get the value of m as also 1 by 2. So L is 1 by 2 and m is also 1 by 2. In this case, answer to this question will be L equals m, and that's your option A. Now here the question is, we need to find this limit L, which is limit n tends to infinite cos pi into under root of n square plus n. Now we'll take this n square out. We can write this as limit n tends to infinite cos pi into n, and here will be 1 plus 1 by n to the power 1 by 2. Now we'll use binomial expansion. We can write limit n tends to infinite cos n pi, and here will be this 1 plus 1 by 2n, and then it will be 1 by 2 and 1 by 2 minus 1, so it will be minus 1 by 8 n square plus higher powers of n. Now this is limit n tends to infinite cos, this is n pi plus pi by 2, and then minus pi by 8n. Now cos n pi plus theta is minus 1 to the power n into cos theta. So it will be this limit n tends to infinite. Now it will be minus 1 to the power n cos pi by 2 and plus this big notation of 1 by n. Now when n tends to infinite, this is oscillating value, minus 1 plus 1, this is cos pi by 2, and this is simply 0. Now cos 90 is 0, and 0 into oscillating value is 0. So answer to this limit is 0, and that's your option C.